Surprise! It's Mrs. Taylor today. We're starting a new chapter, and I'm going to be doing your videos for the next couple of days. So today we're talking about constant rate of change. In your composition book, this is going to be titled 3.1, Constant Rate of Change. You've probably seen this before or heard of this. You should have talked about it last year, but we're going to do a recap. So I don't know if anybody still downloads music anymore, but I used to when I was your age. I know there's Rhapsody and Spotify, but let's just pretend for a second that we're downloading music off of, say, iTunes. I know you all have an iTunes account. So up here I have this table, and I wrote downloading tunes. So the time is going to be our X. So we have 0, 1, 2, 3, 4, and the number of songs. So the constant rate of change is all about the change in Y over the change in X. And that has to be the same for the entire table. It has to be consistent. So we're going to take a look at this. Our difference between, I'm going to start with our Y's. And our difference between, how do we get from 0 to 2? We added 2. How do we get from 2 to 4? Well, we added 4. Sorry, we added 2. We added 2 again. How do we get from 4 to 6? Again, we added 2. How do we get from 6 to 8? We added 2. Okay, so that's consistent. We added 2 the entire time. That's great. Let's check out our Y's, or our X's. How do we get from 0 to 1? We added 1. How do we get from 1 to 2? We added 1. 2 to 3, add 1. 3 to 4, add 1. I'm going to give you a second to go ahead and copy this into your composition book. Make sure you write how you got from each point. So I drew a little arrow, added 2, and up top, added 1. So what I'm going to use now to talk about the constant rate of change is the change in Y over the change in X. Well, since all of our Y's are the same and all of our X's are the same, I can just write 2 over 1. Can we reduce that at all? Yes. We can reduce that to 2. So our constant rate of change is 2. Now, what kind of relationship would you think this is? You are absolutely right. It is a linear relationship. Linear relationships always have a constant rate of change. Okay? So I'm going to flip over to this other example. It's a hot air balloon descent. I know everyone loves hot air balloons. Okay. So over here we have another table, just written a different way. And again, I'm going to start with my Y's. So how do I get from 165 to 143? Well, I subtracted 22. How did I get from 143 to 123? I subtracted 20. How did I get from 123 to 99? I subtracted 24. Okay, so our Y's are not the same, but let's check out our X's and see if we could still have a constant rate of change here. So how did I get from 10 to 20? I added 10. How did I get from 20 to 30? Added 10. 30 to 40, still added 10. Okay, so let's put our change over our Y's to our change over our X's. We already know one thing, our Y's are different and our X's are the same. So that tells me already I don't have a constant rate of change. But I'm just going to write it up here, that way we get in the habit. So 22 over 10, and I can just write one more, negative 20 over 10. Are these two fractions the same thing? No. They are not. They do not equal each other. Therefore, there is no constant rate of change. I put CRC, no constant rate of change. Okay, wonderful. Okay, so this is going to be example number 3. You do not have to draw this graph in your composition notebook, and I would actually suggest you not draw it. But we are going to use this graph to make a table. I think a table is easier to look at to find the constant rate of change, because remember, the constant rate of change is the change in y over the change in x. And so we have to find out how much y is increasing or decreasing and find out how much x is increasing or decreasing. And that proportion has to be the same for every value. Okay, so I'm going to make my table right here. So x and y. So I have my point 1, 5. So 1 is going to go in my x. 5 is going to go in my y. Okay, next point, 2, 8, 4, 14, 7, 23. What's different about this table? You nailed it. The x's are not in exact order. The other example that we looked at, the x's were 1, 2, 3, 4, and they had their own constant rate of change. So let's see what we're going to get here. First, I'm going to start with my y's again. I'm going to find out how much they're increasing or decreasing. So from 5 to 8, how did I get there? I added 3. 5 plus 3 is 8. From 8 to 14, how did I get there? I added 6. 8 plus 6 is 14. From 14 to 23, how did I get there? I added 9. 14 plus 9 is 23. Okay, so now let's look at my x's. How did I get from 1 to 2? I add 1. How did I get from 2 to 4? I add 2. How did I get from 4 to 7? I added 3. Okay? So now let's look at our change in our x over our change in our y. Sorry, change in y over change in x. Okay, let's start over here. So we have 3 over 1. And then we have 6 over 2. These aren't the same number, but let's keep going. Not the same fraction. And then we have 9 over 3. Do we have a constant rate of change? Yes, we do. Why? Because if we reduce these, 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is also 3. Therefore, we do actually have a constant rate of change, even though our fractions were written in a different form. As long as they simplify down to the same number, which they do, that means we have a constant rate of change. Here are your practice problems for tonight. Please do them in your composition notebook. Take a picture and send it in. There are 2. You need to find the constant rate of change in both, if there is one.